Hello, dear friends. I hope you are doing well. My name is Amir Hussein Farzadi, and in this session, we will learn how to use MATLAB for numerical computation and applied numerical methods. And also, we will learn several the methods for root finding, eigenvalue and eigenvectors, interpolation and modeling, numerical, integration and differentiation. And we will work with polynomials. And after that, we will solve differential equations numerically, both ordinary differential equations and partial differential equations. Okay, and finally we will learn how to use MATLAB to solve the optimization problems, actually both quadratic optimization problems and nonlinear optimization problems. And for the linear optimization problems, you can see the previous session. Okay, so let's start with the root finding methods, and then we will cover the other topics as well. Assume that we are going to solve a polynomial equation in the form of an times x to the power of n plus an minus 1 times x to the power of n minus 1, and finally a0 equals to 0. And so this is a polynomial equation, okay? And MATLAB uses this vector to model this polynomial, actually an minus 1, and finally a0. For example, this equation, actually x squared minus x minus 1 equals to 0, is determined by MATLAB using this vector of coefficients 1, minus 1, and minus 1. And you see that this is the coefficient of this term, and this is the coefficient of this term, and this is the final coefficient, okay? And we will define the polynomials using the vector 1, minus 1, and minus 1. And we will use the roots function for finding the roots of polynomial, okay? So let's start find the roots of this equation by MATLAB right now. For example, we define the polynomial as p equals to 1, minus 1, and minus 1. And roots of this polynomial, roots p are these, and if we solve this equation using the quadratic formula, the formula gives us the solution 1 plus minus 2 roots of 5 over 2 or divided by 2, and with minus sign we get approximate solution of minus 0.608 and so on, and for the plus sign we get 1.608 and so on. So these are the solution of this polynomial equation, and MATLAB gave us exactly the same set of solutions. You may call this directly by providing the coefficient, and you may use these find roots for higher order polynomials. For example, suppose x cubed minus 3 times x squared plus 4 times x minus 5 equals to 0, and then the polynomial is given by these coefficients, actually 1, minus 3, 4, and minus 5. And then you can solve this equation, by the roots function in MATLAB. So roots are 1, minus 3, 4, and minus 5. And this says that we have a single real root and we have two complex conjugate roots which are given by these amounts. And the only real root of this equation is given by 2.2134, etc. And if you would like to find roots of any polynomial, you provide the coefficients and the roots function solves the equation.